Okay, so much like yesterday how we did our law of sines, we are going to learn today something about, or tonight, start learning about law of cosines. So law of cosines lets us do the same thing, solve for a triangle, as the law of sines, but the only difference is we use different information. So with law of sines, we needed two angles and a side, or an angle and its opposite side, and then one of the other pieces. Whereas law of cosines, we only need one angle, if that, and it's one angle and two sides or three sides. And so it's just different, allows us to do the same thing when we're given different information. So here's our triangle that we're going to use to kind of get us started. And what our law of cosines says is that if I were to take the side, let's start with a squared, it's going to equal the sum of the squares of the other two sides. So it's starting to look a little Pythagorean theorem-ish. But because it's not right, we can't stop there. So this says you can also take minus 2 times side B times side C times the cosine of angle A. And this pattern, there's a pattern for how all three laws go, but the main idea is that the angle that you have here in your cosine is on the opposite side of the equation as the side that's across from it. So across, across. And then the rest of the other two sides are together here. So b squared c squared minus 2bc. And we can write this for any one of the angles. Angle A, B, or C. It's just a matter of moving the right piece to the opposite side. So if we wanted to do angle B, we'd have to have b squared equals a squared plus c squared minus 2ac cosine angle B. And then similarly, for C, angle C, we have c squared equals b squared plus a squared minus 2ab cosine angle C. So all three of these, they're the same pattern, just making sure that the angle that you have or you're looking for is on the opposite side of the side opposite of it in our picture. And so what you notice is that we only ever need one angle or three sides. If we have two angles and one side, that would mean we'd have to use law of sines. So it's just letting us use different information to do the same thing. So we're going to solve, I believe, we're going to solve for two triangles using law of cosines. And then in class tomorrow, I'm going to go over Heron's formula, which, just like how law of sines had its area formula that you could use, Heron's formula is a different one for area of a triangle that just that actually doesn't go with cosines. You don't need to know a sine or a cosine of anything. Unlike the law of sines area, you had to know sine of an angle. So Heron's formula is just another area formula that allows us to quickly and easily find the area of a triangle without having to find the altitude or anything like that. So we'll do this in class tomorrow, but we're going to go through just two examples here where we're going to solve for a triangle, but we're going to have to use our law of cosines. So solve for the triangle. So in our first one here, I'm going to tell you that A is 18.2, C is 17, and angle B is 39 degrees. So again, remember, lowercase letters means they're talking about side lengths. So we're given two sides and one angle. And so I'm going to sketch out a picture just because pictures kind of help clarify and see things. Doesn't matter what you call A, B, C as long as you fill in the appropriate sides with the given information. So A, angle A is here, so that means my side A is over here. C, here's my angle C, so side C is over here. So that would make this one side B, and angle B is 39 degrees. So to start off, I'm going to find side B. So using our law of cosines, because I know the angle opposite of it, I can say B squared is going to equal A squared plus C squared minus 2AC times the cosine of angle B, which is 39 degrees. So if you're really confident and stealthy with a calculator, you can type this all in at once. I usually like to do a couple of little steps just to make sure I don't make any unnecessary errors. So I'm going to do those. So 18 squared, no, 18.2 squared plus 17 squared. So this will give me 620.24 minus 2 times 18.2 times 17 gives me 618.8 cosine 39. So now I'm just going to plug this whole thing in together in my calculator. So 620.24 minus 618.8 cosine 39, enter, and I get 139.342. Now that's B squared. So to find B, we have to square root it. So I'm going to square root my answer here, and I have 11.804 as my length of B. Okay, so that's our first part. Now we have all three sides, but remember, to solve the triangle, we have to also find all three angles. So from here, we can do a couple things. Now that we know an angle and its side opposite, and we want to maybe find another angle, you can go and use law of sines to help you with finding the third angle, or you can use law of cosines as well. So you have some more options. Once you have this third side across from the angle, you now can use law of sines. You can mix up using your laws because they all give us the same information. Because we're practicing law of cosines, I'm going to use law of cosines, but if you wanted to use law of sines, you technically could. Okay, so there's my B. Now I'm going to do the same thing with my law of cosines, but I'm going to find, let's say angle A. So let's find angle A here. So that means if I'm finding this angle, the side opposite of it, 18.2 squared equals 17 squared plus 11.804 squared minus 2 times 17 times 11.804 cosine angle A. Okay, so just like in the last one, I'm going to do a couple of little steps rather than typing everything into a calculator at once, just to make sure I don't make any little mistakes. So I'm going to first find out what is 18.2 squared, 331.24, and then I'm going to find out what is all of this. So 17 squared plus 11.804 squared, and I get 428.334 when I round to 3 decimal places. And then lastly, I'm going to figure out what this coefficient of my cosine is. So 2 times 17 times 11.804, and I get 401.336 cosine A. So now I need to solve for my cosine of A. I need to get this by itself so that I can inverse and find A. So I'm going to subtract 428.334 to both sides. So 331.24 minus 428.334, and I get negative 97.094 equals negative 401.336 cosine A. Next, divide both sides by the negative 401.336. So divide by negative 401.336, and I get 0.2419, I'm going to go 4 here, equals cosine of A. So now to solve for A, to move that cosine to the other side, we have to inverse it. So A is going to equal the inverse cosine of 0.2419. So I'm going to go back to my calculator, inverse cosine of 0.2419, and we get 75.999, so that'll be 76 when we round for angle A. So then lastly, so we have our missing side. We now have this angle as 76. So then how do we find the last angle? We can use the fact that all of them have to add up to 180. So 180 minus 39 minus 76 equals 65. So that means angle C is 65. Okay, so again, did we have to do law of cosines here? No, we could have done law of sines, but for practice sake, I wanted to show you how you could do law of cosines as well. So I'm actually going to save our second one for in class, just to make sure if there's any questions or clarifications needed on this type, that we can do one together and make sure that we get all those questions answered.